Now let's look at how we can add type classes to our type system. So far we've seen type schemes that were of the form for all A, T. But from now on, type schemes will look more general. They'll be of the form for all A that belong to one of the type classes in the set gamma T. So this gamma is a set or family of type classes. An expression which has this type scheme has the type for every type in the type classes. So if E has the type for all A, gamma T, then we know that E in our type environment will have type T, where A substitutes by T1 for every type T1 in any one of the type classes in big gamma. So big gamma is a collection of type classes. So before in our type system we had type judgments that were of the form given a type environment, E has type T. From now on we need something a bit more involved, because not only do we have a type environment, E tells us for every variable what its type is, so it's a function from variables to types. We still have type environments, but now we also need to have a class environment. This is a typed class environment. And the type class environment C is a function from types to type classes. And given a type class environment, we can then type an expression. So a type class environment C is a collection of bindings of the form A1, gamma 1, up to a k, gamma k, where the A's are type variables, and these are sets of type classes. And when we write that T double colon gamma, this means that type T is in each of the type classes. In gamma. So in order for this to be interesting, we extend the language a bit with instance declarations. And instance declarations are of the form given instance requirements in C prime, we conclude that T belongs to the type class gamma. An example of an instance declaration is the following. Suppose A1 is in the type class num and A2 is in the type class num. Then the type frac A1 A2 is a type in the type class numVect. So those are instance declarations. We also introduce a notion of type class judgments. They're of the form C turnstile C prime. And how do we read that? Well, given the type class bindings in C, we can then conclude that we also have the type class bindings in C prime. And this relation is defined by a collection of rules. And here they come. There's a rule called lookup. We have to have a lookup rule whenever we have environments around. If we have a type class environment C, then we can conclude that the type A has type class gamma if it's the case that in the type class environment A belongs to a collection of type classes, one of which is gamma. So that's just a lookup rule. It says that A has type class gamma. The type A has type class gamma if gamma is one of the type classes mentioned for A in the type class environment. There's also another important rule which talks about instance declarations. If we know that the type class environment entails that we have type class information C prime, and if we have an instance declaration that says that if the instance declarations in C prime are true, then T has type class gamma, then we know that T has type class gamma. The two last rules for type class judgments are class 1 and class 2. Class 1 says that if we can conclude that the type T has the type class gamma 1, and we can also conclude that the type T has type class gamma n, then we can conclude that T has all the type classes, is a member of all the type classes in gamma 1 up to gamma n. This is not a surprising rule. The other class rule is also not surprising, because it says that if we can conclude that T1 is a member of all the type classes in gamma 1, and we can conclude that Gn is a member of all the type classes in gamma n, then we can conclude the information that we have all of these. And it's this rule that lets us conclude judgments of the form C entails C prime. So now that we have type classes involved, we don't really need to modify very much. In our revised type system, everything as before. Judgments are of the form given a type environment and a type class environment, E has type T. All rules are as before, except that we now add the type class environment, but we now add two new rules. And the two new rules that we add are a rule that resembles projection. We call it for all elim. It's the specialization rule. It says that if we know that E has the type scheme for all A in gamma T, and we know, given our type class environment, that T is a type in all the type classes in gamma, then we can conclude that E has type T, where A can be instantiated to T. So this is a new version of the specialization rule that we saw in the parametric polymorph type system. Here we are simply relativizing our quantification to a collection of type classes. The other rule that we need to have is the one that lets us conclude a type scheme. It's the one that says that if we have a type environment C and a type environment E, and a type class environment in which A is a member of all the type classes in gamma, and we can then conclude that E has type T, then what do we know? Well, we know that given E and C, E has type for all A in gamma T, and that's the case if A is not a free type variable in E. If that's the case, we know that we have made no assumptions about A, so we can add a universal quantifier in front of the type. So that's really all we need to deal with type classes in this setting.